So we'll give a warm applause to Arjun.
Hello, I'm Arjun. I'm from the SRE team. And recently, we started a movement of our shop monolith to microservices in the cloud. And to ensure that these services are performant enough that they live up to the current load and they can scale further, we did some load tests. And I wanted to share our learnings and our findings with you. So this talk is all about that. So we'll go about it in 4 steps. One is the background, what's there right now. The infrastructure is how it will be in the future. All the new microservices, where they are deployed, how they are deployed. Then the tool that we use for testing, which is called Locust, why we use it, and how we use it. And finally, some of the common pitfalls and which are not documented, which often come up, and the procedure, because that's quite important as well. So the background, like I said, it's a very large monolith which is deployed in a data center. Right now, most of the shop traffic still goes to the data center. But parts of this are being removed, and they are being made into microservices. The old shop still needs to talk to these microservices for that particular functionality. So we have a hybrid system where the part of the traffic goes to the data center and then it's routed to AWS. So Arnaud just had a talk about how agile stuff works, and we kind of have the same thing. We have, I think, a little more freedom than in most companies. Teams choose their own stack. Not only that, they have their own AWS account because they are responsible really end to end for everything. So they build it, they maintain it, they even deploy it, they even manage the cost of that account. Well, they don't pay for it, but they have to be responsible for it. And services like testing or any specialized services, like in our case, performance engineering, are things that they get from other teams like ours. Or say they need a security audit, there's a security team which does a security audit. We use a API-first approach for our microservices, which means that we define the API first. We use Swagger for that. It's called Open API now, which means that it's all HTTP. All the microservices talk over HTTP over the internet. The contracts are defined first, which means that you cannot inadvertently break any of these APIs by code changes, because your contract is actually the point. Is the point where the other services get in touch with the microservice, and all this communication is also secured by OAuth, so you know who is doing what and which service is doing what. So why did we do the load tests? As I said, the new microservices were developed from scratch. We had to ensure performance. There are some issues that occur only under load. So we had to either generate a lot of traffic on these microservices, or we had to sustain quite a high number of users over a prolonged period to see these issues. So this was these were the two main use cases for load testing. And then tuning of parameters, like say a thread pool, then your circuit breakers, and other stuff like that. And optimizing the stack, choosing the right kind of instance, choosing your database size, anything. So load testing gives you a good insight into like where are your bottlenecks and what you need to work on next. So about the infrastructure, what we are using now, what we will be using, we have already moved a little bit of our a little bit of our functionality to AWS. For monitoring, we have our homegrown monitoring solution called Zmon. So it's a time series database with Grafana, but it also it's more than that. And we have instrumentation for different sorts of binaries and stuff. Monitoring is very important in load testing. So without monitoring, load testing, you might as well not do it. Every metric has to be measured. Without this, you will never find out if where your bottlenecks are, why you are slow. All you will know is that you are not able to sustain a certain amount of traffic. So this is what a microservice looks like. A typical microservice, we have Route 53. So every microservice is reachable over the internet. So Route 53, so we use CloudFormation in the background, but CloudFormation does not support versioning of stacks directly. So we version them by using by giving them different DNS names. Then after that comes a load balancer, an elastic load balancer. This load balancer has a couple of EC2 instances behind it, which all are in an ASG, so then they can scale out as based on the amount of traffic. And all these EC2 instances talk to some kind of data store. All the EC2 instances are stateless; they don't have any state, so they can die, they can be replaced at any time. Oops. Okay, a little talk about elastic load balancers. So they are basically just EC2 instances, but they appear as a black box. So you cannot really tell if they are, when you scale, if as the traffic increases, if they are actually scaling out. So you cannot start off with a very high traffic, and then the load balancer will not be able to keep up with that traffic. So it scales over time. We did a test where we had to generate around 200,000 requests a second, and it took a couple of hours for it to reach that kind of throughput. You can avoid all this by pre-warming. Pre-warming is basically contacting the AWS tech support and telling them that you are going to have some large spike in traffic. But as you remember, we have microservices and all of them have load balancers. So it is like we kind of at some point lose track where how many load balancers have to be pre-warmed. So it really doesn't work for us. And the only way to observe if the scaling actually happens is by looking at the DNS results. So we look at the DNS, and if we see the number of IPs increasing, or if the IPs change, that means that the load balancer has probably scaled up. So this is something that you have to look out for when you are doing load testing in AWS particularly. So we looked at the background, the infrastructure where the microservices are deployed, and now let's have a look at the tool that we use, Locust. I really like this. And if many of you probably have heard of JMeter and other tools like that, but JMeter is quite simple. All you give it is a list of URLs, and it calls all those URLs. But what you want to test is functionality multiplied by thousands or tens of thousands. So you want, say, if you have a shopping cart, you want to take an item, take it out, increase the quantity of that item. You can't really do that with something like JMeter, or rather, you cannot add that randomness you need with JMeter. So you cannot have different kinds of SKU IDs or article IDs. So Locust kind of fills that gap. If you are a Scala programmer, probably you can use Gatling, which is very similar. It's a Python-based tool. It uses G-Event, so the lib.io, I think. And we also have to run multiple processes because of the global interpreter lock. It supports distributed mode, so most tools like AB and there are a couple of others, I think Siege, they're not designed for distributed mode. There is Bees with machine guns, which actually takes AB and runs it on multiple machines, but that works over SSH, so it doesn't really scale well when you have multiple slaves. Instead, Locust uses 0MQ, and it can go up to hundreds of slave nodes. So you can have hundreds of machines calling a master, reporting back to a master, and you can look at the statistics, incoming statistics in real time. It all runs through a web interface, so it's really easy to start and stop. And yeah, so you can just stop if something's going really wrong. So a little bit about the workflow, what a Locust script looks like. You have every Locust. So in Locust terminology, a Locust is a user because you are trying to swarm your website or your application with many users. You can then each user has a couple of task sets. Say there is the browsing, could be a task set. The shopping cart could be another task set. And each of these task sets could have different weights related to associated with them. So the user would perform those tasks in that ratio. So if you look at the diagram, you can see that there is task 1, task 2, and task 3. They all belong to a particular task set. They are all executed in random order, so any of them could be called after each other. And there is random amounts of delay between them. So it more realistically simulates the interaction of a user with, say, a website or even a microservice. Other features, you can group the requests because you are dynamically generating URLs to be called. You can group them all together. This is quite an important feature. And in theory, it can be used for testing any request response protocol. So we did use it to test some TCP stuff as well. I'm kind of running out of time, so maybe I'll quickly go over this. So there is a spawn rate for a Locust. So you start off, say you want to have 300 users per second at any moment interacting with the website. You spawn it at a certain rate. You don't start off with 300 users. Probably your caches are not primed or your load balancer has not scaled up. So you can start off with a small number. Say that spawn 5 users a second and go up to 300 users. So it takes 60 seconds. Your load balancers have the time to scale up. You can control the failures of these requests as well. So you can, if your API returns say a 400, you can say that this is actually a success. This is quite important if you are testing APIs where 400 means the article was not present. And yes, so randomized delays, and however, there is no support for sequences of tasks. Some pitfalls and procedures. Load testing is dangerous. There are many, many bad things that can happen when you load test. So it is best to keep everyone informed If you have downstream services, if you're testing a service and which depends on downstream services, please inform not the teams which are responsible for that service, but anyone else who might be affected by them. This will also avoid issues like if somebody is trying to tune their stack or something and they have some weird stuff going on, they'll know, okay, somebody is going to load test. So this way you won't have weird issues showing up in your results. Check and double check you're targeting the right system. This can happen quite often that you maybe hit this live system when you are actually trying to test the staging system. Always keep an eye on the status. Like the status is if you're testing a live system, look at everything related to it. You will see if you see even the slightest anomaly, just stop the tests. Monitor everything. Monitoring is, like I said, is very important. The reason you need monitoring is to identify bottlenecks. To give you an example, if you have, say you have monitoring only for the CPU or the RAM, and you say my microservice is really not doing any disk I/O related work, and then you don't monitor disks. What you don't know is that you are also actually doing some logging, and when you were developing, it was fine because the logs were being written at a slow rate. But when you load test, all of a sudden there's a huge amount of logging, and then the log doesn't get rotated, and all your machines go down. So it's very important that you monitor everything. Don't even start load testing without monitoring. You will not be able to know why your results are bad. Ramp traffic gradually. One, because it gives people time to respond to anything that happens. Anyone has to manually scale something, they can do that. Resource bottlenecks, be very careful about any resources that you should not be using over a certain limit. So yeah, and finally, use circuit breakers. So circuit breakers are a sort of a software pattern which prevents downstream services by being inundated by requests. So if the downstream service goes down, it will just stop making the requests and won't make any more requests. So this has saved our life more than once. Finally, how we actually do the load test. Like this is, let's say, a week-long process. First collect the requirements. Understand why people want to do load tests. Often, teams come to us saying that we want a load test, and then we think, okay, they probably want to see if their service scales. But what they actually want to do is find out why there is a memory leak in their application. So what they actually want is sort of moderate load over a sustained period. So understand this right at the outset. Have clarity on this matter. Understand the architecture. Some applications might have databases. So if you do not have sufficient randomness in your load test, you will find that there is a database which is actually caching something, and you get good results. But in reality, the performance might be quite bad. Ensure monitoring is placed. So before you do the actual load testing, have a checklist. Say monitor this, and see that it's in place. Have multiple stacks ready if you want to optimize your stack, if you want to find the best possible, like EC2 instances or any sort of other parameter, like I say RAM size or whatever. You have all machines with all of these types ready, and then you test them one after the other. This will kind of reduce any. So this will give you a better baseline, so you can compare them. Health checks in load balancers are very tricky. Often they work when there is no load because the application can respond back in time. But during load tests, the application might take, the servers might take more time to respond to a health check. So increase the health check period. Run the tests. After you do all these 6 things, you probably should run the test. Finally, analyze monitoring and report the results. So in our case, if you're doing it for your own team, then it's okay, but we do it for other teams, so we have to sometimes break down everything and say that, so we started off with so many requests, we went up to so many requests. At this point, we saw that a new machine was started. So you need to understand all this and so that it's probably they can get more meaning out of these load tests. That's it. This is the final we are hiring slide. We have tons of job openings. We are also an open source first company, which means that if you're not doing anything related to our shop, then you can actually just open source right at the start. You don't need to get any approval. We also have many tech events here in Berlin at our Mollstrasse office. You can come by and follow us at Zalando Tech. Thank you.
Thank you. Cool talk, Arjun. Any questions for Arjun? No? Yes?
Yep.
From the back.
What kind of improvements have you noticed since you started load testing?
I'm sorry?
What kind of improvements have you noticed since you started load testing? Are the software lasting longer? What improvements do you find?
Out of the what?
Since you're doing load testing,
yeah.
What improvements have you noticed in the software?
Okay, so there is no one big monolith. We are not load testing the monolith. We load test the microservices. So in different microservices, we have found different problems. Things like logging. In some issues, it's mostly about finding these bottlenecks. That's basically it. If I could sum it up in 2 words, it's just monitoring and bottlenecks. So in different microservices, we have found different things that we could improve. We had things like we had a monitoring solution actually from a third party, which caused memory leaks. So. Yeah, that was very strange. But the only way we could establish that is by doing these load tests for 2 or 3 days. So those are the things that we improved, and those are the things that we found. So.
Another question coming up?
Yeah, I have 2 questions actually. One is on the organizational side. Are you working with a team specifically on load testing, or are you kind of a consultant for every development team? So how is it organized, basically? And the second one is if you could detail maybe about the circuit breakers, historics, how you included that. Yeah.
Okay. So to give you an estimate, there are around, I think, 2,000 people who work in technology in Berlin. So we don't work with all of them. So some of them are, there are around 800 people who work at Mollstrasse down the road here. And they're all divided into teams. Some of these teams do advertising, all kinds of things. But we mostly work with the shop team, so the Zalando.de people. They are responsible for components like the article reviews or the cart service, or something like the checkout, or there is a delivery availability service. So they come to us, and we understand their requirements, we understand their architecture, and then we design these load tests for them. I hope that answers your first part. And the second part is the circuit breakers. So circuit breakers is apparently it's a software pattern. We don't implement it directly. It has to be implemented in the microservice. So whenever you have one service calling the other, it doesn't queues these, and it has a connection pool which it uses to call the downstream service. So if the downstream service stops responding, the circuit is open. And that means no more requests are sent downstream. this gives time for the downstream service to recover. So what we did was basically since we have a lot of requests and there is no a magic number on the number of threads for this circuit breaker. So this needed tuning in multiple microservices, and we did that with load testing. So, yeah.
All right, thank you.
See another question here.
Yeah, but we are a little bit over schedule, so what I suggest is that you guys meet in the coffee break, which we have now. Since we're a bit over schedule, we'll take 5 minutes longer for the coffee break, so we meet back again at 10 minutes to 3. Thank you, Arjun.